Hello, our team designed a process of methanol production through Bireformation and Fischer-Tropsch synthesis. My name is Matthias Amezquita Fox.
I'm Akari Otsuki.
My name is Rangao.
My name is Jose Jordan Cruz.
Natural gas is primarily methane, a greenhouse gas that is harmful to the environment. We design our process with Aspen Plus to synthesize natural gas into useful and much less harmful substance, methanol. This is created via bireforming of methane followed by Fischer-Tropsch synthesis. The process could be applied at any landfill or livestock area producing methane. In-depth analysis was done for large-scale production in partnership with local fueling station in Fort Worth, Texas. Bireforming consists SMR and DMR process. Then the product stream will be sent to the Fischer-Tropsch synthesis. This produces syngas with hydrogen carbon monoxide molar ratio closer to 2:1. The optimal feed stream to Fischer-Tropsch gas to liquid synthesis. Optimized nickel-based and iron-based catalysts were used to increase the methanol production and make the process more economically sustainable. Here is our SMR DMR Fischer-Tropsch reaction.
These are the current market prices for our process feed materials, which are natural gas consisting of methane, carbon dioxide, and hydrogen, and liquid water. The water will be purchased from whatever city the process is being implemented in. Again, for our estimations, we're using Fort Worth, Texas as the location for all of the costing estimations. However, producing natural gas from a landfill is actually an expensive and difficult process. So for our project, we are planning on buying it and piping it directly into our process from an independent seller, which is Waste Management in this case. So there are lots of harmful natural gas collecting processes in the country. So we wanted to get our natural gas from a process that will actually benefit the environment. And Waste Management actually has a program where they produce natural gas through anaerobic digestion of collected residential and commercial waste. Waste Management will actually take care of all the collection, all the digestion, any post-collection processing required, like dewatering, filtration, and pressurization. And then they will pipe the natural gas directly off to any industrial customers like our process. So this is how we ensure that our process feed is coming from the right place and will benefit the environment overall. The final product of our process is liquid methanol, which will be either stored on site or piped directly to any customer if that is more convenient. This is the current price for methanol, but along with any of the other prices listed in the earlier slide, these markets are going to have to be consistently monitored to make sure that the process stays economically sustainable and with a solid profit margin.
Here is our Aspen flowsheet for SMR and DMR, and here is our Aspen flowsheet for Fischer-Tropsch. For the PFD, we are having CH4 and water entering here and reacting in the SMR reactor here. Unwanted water will be leaving here, and the gas stream will be reacting along with CO2 H4 in the DMR reactor here. The unwanted water will be leaving here before reacting in the Fischer-Tropsch reactor here. The unreacted syngas will be leaving here, and the methanol and water will be reacting here. It will be leaving here.
So this slide is about environmental regulatory information. The first column is all the reactants in the project, which are hydrogen, methane, carbon dioxide, and carbon dioxide. In the third column, the exposure limits, TWA means time weighted average, which means the average exposure to a contaminant where workers may be exposed without any adverse effect over an 8-hour period. And the first column is based on an act of hazardous chemical inventory. All these ingredients has been classified as a fire hazard and a health hazard in acute and chronic form. The final column is transport of dangerous good regulations. It has the proper shipping name, 2 forbidden transportation method, and a limitation weight for cargo aircraft. And on the bottom side notes, that is different standard regulations which related with our project. And the exposure control and the individual production is very important and necessary in engineering industry. In this project, it could only start with adequate ventilation and keep vapor or dust concentration below any lower explosive limits to provide the worker with a safe exposure to any airborne contaminants. And emission from ventilation of work process equipment should be regularly checked to ensure they comply with all the requirements, and also put attention on eye and face production in the individual measures. The generation of waste should be avoided or minimized wherever possible. Disposal of any byproducts should comply with the requirements from environmental production or any waste disposal legislations.
So in our economics, we have our greatest asset, which is the methanol produced. We have a 1,100 million US dollars a year. Once everything in the production is in a steady state, and our expenses will be of about 760 million a year the first year, for that we counting the capital costs, and this capital costs are greater than our operation costs. So our energy costs also are one of our main operation costs, which are pretty decent on the electricity. We reduce the electricity by about 1,000 kilowatt hour for both of our Fischer, Tropsch, and SMR VMR processes. And this cost of per year of electrical is about 6.7 million a year. So now the next slide, please. So our uncertainties for this project is how much time this will take, which contractor we're gonna get for this to happen, within the market fluctuation, as well as the exact location in Fort Worth or in the vicinity of. We were recommended also by our mentor to be open with other states as well as Arizona or New Mexico, and also the nearby ways of water and the plant selection. For as the economics, this project is pretty much focused on Fort Worth though. So yeah, next slide. And the acknowledgements are for Adriana Brush, Kim Ogden, and Thomas Alden, and the University of Arizona Chemical and Environmental Engineering Department. Thank you so much for supporting us, giving us resources, and all the help that we needed through this process. Thank you so much.